Today I'm going to be demonstrating how to do a Hardy-Weinberg problem. This is the equation that we use to solve for all questions. P squared stands for homozygous dominant. Now we know that homo means same, and when we say dominant, we mean to use a capital letter, so big T, big T. 2PQ stands for heterozygous, which means big T, little t. Q squared is homozygous recessive. Homo means same, and recessive means lowercase letter, so lowercase t, lowercase t. P stands for dominant allele frequency. And in order to calculate this, you use your observed value divided by your total value. Q stands for your recessive allele frequency, and the same thing. To calculate it, you use your observed value divided by your total value. And we know that P plus Q equals 1. When they're talking about allele frequency, they're pertaining to the P and Q values. When they're talking about individual organisms or people, phenotypes, they're referring to the equation, the P squared plus 2PQ plus Q squared. Now here's how to do a problem. First, you're going to read the problem carefully and know what is being given. Then, you're going to read the question and know what is being asked of you. Finally, you're going to use the equation P squared plus 2PQ plus Q1 equals 1 to isolate your variables and solve for the problem. Now here's a problem. 25% of the animal population do not have tusks. They receive the recessive genes. So in this problem, it's telling us that 25% don't have it and that they are recessive. Now, from the equation shown earlier, we know that Q squared stands for homozygous recessive. And we also know that when they're talking about populations or individuals, they're talking about the allele frequency. So here, Q squared equals 0.25. Usually, they will always give you the Q or Q squared. Now we want to get Q by itself. So the square root of Q squared equals the square root of 0.25. And Q ends up equaling 0.5. We also know that P plus Q equals 1. So we create an algebraic equation. P plus 0.5 equals 1. You isolate your variables, so you subtract 0.5 from each side, and you end up getting P equals 0.5. Here are some other questions. What percentage of elephants in the population have tusks? So we're going to use the equation 1 minus Q squared. Since in the problem it states 25% of elephants don't have tusks, we're subtracting it from 1. So 1 minus 0.25 gives you 0.75. So 75% of the population do have tusks. What is the frequency of the dominant and recessive alleles? Now when we're talking about frequencies, we're talking about your P values and your Q values. And we calculated already before, and we got P equals 0.5 and Q equals 0.5. So your dominant frequency equals 0.5 and your recessive frequency equals 0.5. What percentage of the population are heterozygous for the trait? Now we use our equation 2PQ, and we get 2 times 0.5 times 0.5 equals 0.5, which gives you 50%. And that is how you do a Hardy-Weinberg problem.